This video was recorded just a few days before the August 21, 2017 eclipse.
I'm sure you've noticed the surge in the number of videos, news clips, and commentaries all over the internet, TV, and everywhere about the upcoming eclipse of August 21st, 2017, and the fears that it will bring doomsday, the end of the world, or horrible disasters like earthquakes or volcanic eruptions. These videos pop up all the time, all over the place, to scare the bejesus out of some. Are they right or are they crazy? That's the topic of this video, but from the scientific perspective only. Let's take a look. Before we can begin to explain the relationship between eclipses and earthquakes and other natural phenomena, we have to know a few terms. The first one is perihelion, which is the moment in which the sun is closest to the earth, and usually happens around the 3rd of January or 14 days after winter solstice. The second one is perigee, the moment at which the moon is closest to the earth, and it happens once a month. And the third one is syzygy, or the moment at which the moon, sun, and earth are aligned. This happens every full and new moon, though the alignment is not always perfect, or in other words, complete. Perigean springtide happens when there's syzygy, or alignment of the sun, moon, and earth, at the time the moon is in perigee, meaning closest to the earth. Therefore, perigean springtides occur during a supermoon. Solar eclipse can only occur during a new moon, which is the day when you cannot see the moon. That's why we can only see its silhouette as it passes between the earth and the sun. If the moon is far from the earth at the moment of alignment or syzygy, the result is an annular eclipse, which is a form of partial eclipse. If the new moon is close to earth, in and close to perigee, the result is a total eclipse. Most of the time, an incomplete overlap of the orbits of the moon, sun, and earth explain why we do not have eclipses every month, and when they occur, they're often partial. Total solar eclipses are not as common because they require the perfect alignment of the orbits of the sun, moon, and earth during a new moon. They also seem to be less common because not everybody sees it. They're only seen in one particular part of the planet each time they happen. Okay, now let's get deeper. Now that we understand the basics of the interactions between the sun, moon, and earth, we can begin to understand how they affect the earthquake activity on earth. Some of the earlier evidence that the interactions between the sun, moon, and earth could lead to earthquakes on earth came from the Apollo missions. The Apollo astronauts observed that moonquakes happen most common at perigee, which is the point where the moon is closest to the earth. The United States Geological Society believes that although the increased gravitational pull of the Earth on the moon at perigee, at the closest point, can explain moonquakes, it cannot explain earthquakes because the moon is too small to exert significant forces on the bigger planet Earth. But we do know some other interesting facts. We do know that ocean tides are caused mostly by the gravitational pull of the moon and to a lesser extent, 30%, of the sun as well. We know that the same gravitational forces of the moon and sun that cause tides in the oceans also cause deformations of the crust or earth tides. And we know that while ocean tides may swing by a meter or more every day, earth tides cause changes in crust height of only a few centimeters. And we also know that when the moon, sun, and earth are aligned every full moon or a new moon, the gravitational forces on each other add up. This, in scientific terms, is called a period of high tidal stress. The tidal stress is particularly strong when the moon and sun are closer to the earth, which are called perihelion and perigee respectively. And it is during those periods of high tidal stress that we could expect a greater effect on the ocean tides and the earth tides. So far, it seems to make sense that an eclipse could cause earthquakes. Do we have examples? Of course we do, but this is what they call anecdotal evidence in science. Anecdotal evidence means that it's based on the observation of a few people. Science needs tons of information, tons of data before they can conclude anything. Now let's see some of the evidence. There was a guy called Nigel Gray who in 2016 heard that a supermoon would occur on November 14, 2016. He predicted in a viral Facebook post that people should prepare for a strong earthquake on that date. As a matter of fact, on November 14, 2016, New Zealand was hit by a 7.5 magnitude earthquake. Interestingly enough, that year 2016 had 3 supermoons, one on October 16, one on November 14th, and one on December 14th. Let's hear another example. In this case, it's Jim Berkland. Jim Berkland is a geologist that tried to predict earthquake based on the position of the moon and the number of lost pets reported in newspapers. Mr. Berkland predicted that an earthquake would happen on or around October 15, 1989, when the moon would be in perigee closest to Earth and full, that is, a supermoon. That made him famous because 2 days later, on October 17, 1989, an earthquake happened during a World Series baseball game in Oakland. His theories were supported only by the earthquake of 1964 in Alaska, which happened during a full moon. The United States Geological Society does not accept Berkland's theories because his data is so scarce. While the December 26, 2004 9.1 magnitude earthquake and tsunami that hit Sumatra happened during a full moon and close to perihelion and supports Berkland's views, the March 11, 2011 Tohoku, Japan earthquake and tsunami happened 8 days before a supermoon, and the moon phase was not full but waxing crescent and was not at perigee. Also, the biggest earthquake ever recorded in 1960 was the Valdivia earthquake in Chile, and it had a magnitude of 9.6. This earthquake happened during a waning crescent. Because there's so many factors that can trigger or prevent an earthquake, many scientists think that there is no proof that syzygy, perihelion, perigee, or anything like this can cause earthquake or volcanic eruptions. But remember, scientists require proof and are not easily convinced because they have a huge responsibility with the public. There are other scientists that do believe that the relationship exists, and even those who do not yet believe may have reasonable doubt, and that's why they continue to study gravity, gravitational waves, and their relationship to earthquakes and volcanic eruptions. Earthquake guru Mark Quigley from the University of Melbourne does believe that it's true that tidal deformations of the Earth due to movements of the Sun and Moon could trigger an earthquake in specific situations. He thinks that small changes in the gravitational pulls could trigger the failure of active faults that are about to slip or fail. On September 12, 2016, the scientific journal Nature Geoscience published an article that is groundbreaking. This is not anecdote, this is science. The article was published by Satoshi Ide from the University of Tokyo. The team gathered the data of more than 10,000 earthquakes of around magnitude 5.5 or higher. The team found that an earthquake that began during the time of high tidal stress was more likely to grow to a magnitude 8 or higher. Remember that the high tidal stress periods are when the moon, sun, and earth are aligned, especially at perihelion or perigee. Therefore, following the same logic, the worst case scenario would be when 3 things happen at the same time. 1. The moon at perigee, 2. The sun at perihelion, and 3. Perfect alignment of the sun, moon, and earth, or perfect syzygy at full moon or new moon. These circumstances would also apply to ocean tides, since theoretically the drastic high or low tides of the ensuing perigean spring tide could cause movement of subduction zones leading to earthquakes. This combination would be theoretically the perfect storm to trigger an earthquake. So let's see what we have for the eclipse of August 21st, 2017. Number one, it is a solar eclipse, so we know that we will have a new moon. Number two, we know that the eclipse will be total, so we know that the alignment or syzygy is perfect and that the moon will be close to the Earth. As a matter of fact, the moon will be rather close since perigee occurs on August 18, 2017, and the upcoming total solar eclipse happens on the 21st. And we know that the effects of gravitational pulls are not seen immediately, but that they lag many hours behind the movements and locations of the moon and sun. And number three, because we will be just past perigee and complete perfect alignment of the sun, moon, and earth, we can expect a high tidal stress those days surrounding August 21st, 2017, meaning almost perigean spring tides in the ocean and larger deformations of the earth crust. We're not at perihelion, the point at which the sun is closest to Earth, so that's not a factor for our eclipse. Good, that is a plus. So if we follow the logic, it's not crazy to sweat a little when we think about these things. There is a scientific basis for our concerns, and plenty of scientists would share that concern. The good thing is that eclipses or alignments don't always coincide with earthquakes in time. As a matter of fact, if you remember that partial alignments between the Earth, Moon, and Sun occur twice a month, that perigee happens every month, that perihelion happens once a year, and that solar eclipses happen somewhere on Earth every 18 months, we can say that most of the time, these things do not have any effect in triggering earthquakes or volcanic eruptions. Another good thing is that many more things have to happen for an earthquake or volcanic eruption to occur. The relative movements of the Sun, Moon, and Earth are not the only factor. And the last good thing is the fact that there will be an eclipse doesn't add any additional risk to the syzygy itself. Having said all this, I totally get it. The facts are creepy. Reality is scarier than fiction. You do not need any concocted prophecies or conspiracy theories to be concerned. But in conclusion, what is most likely is that you will be treated to one of the most wonderful and unique events in the universe, and we should all enjoy it. So stay informed, stay awake, enjoy, and be prepared.
Of course, now we know the eclipse passed without triggering major earthquakes. But it's fascinating to revisit the questions people had back in 2017.